Okay, we're going to take a look at numbers 1 through 4 in section 5.4. They're kind of a multi-step activity. First three are pretty straightforward. In the first problem, you're going to just evaluate this polynomial function at x equals 6. Again, your polynomial function might be slightly different, different coefficients, different value of x. Hopefully everyone's good with this, right? We simply plug in by replacing x with 6 everywhere, and then we do the evaluation. 6 to the fourth power is 1,296. 6 squared is 36. I multiply here and here, and then I subtract and add, and we get the output to this function. So input 6, output that. The next step is to just review multiplying polynomials. And so expand means to multiply out this product here. You have a trinomial times a binomial. So remember how this basically works when we're multiplying polynomials. Each term in the polynomial on the left needs to be multiplied by each term of the polynomial on the right. So I'm going to multiply 7x to the fourth times 2x squared and then times 8. Then I'm going to multiply 9x squared times 2x squared and 8. And finally 3 times 2x squared and 3 times 8. So I've got 6 products. I simplify, of course, multiply the coefficients. 7 times 2 is 14. And remember, when I'm multiplying like bases, I'm going to add these exponents, right? X to the fourth times x squared is x to the sixth. And then on down the line, I'll multiply the numerical coefficients. Of course, adding the exponents gives me these 6 terms. And then I should combine like terms. Like terms are ones where the variable is to the same power. So these two are like. I add 56 and 18 to get 74, x to the fourth. 72 x squared plus 6x squared is 78x squared. And then I have my first and last term. And there's my polynomial. In step number 3, you watch the video, and they're going to show you how to evaluate an integral using the fundamental theorem of calculus part 1. I'm going to do the one that I was given. Again, yours should be very similar. Is this integrating from 0 to 2, this polynomial function? So number 1 is to expand this out, much like we expanded the one up here out, but much simpler. Here I'll multiply the first two terms together. 8 times 4 is 32. X squared times x is x cubed. And then I'll multiply the outer terms. 8 times 3 is 24 x squared. The inner is negative 6 times positive 4x is negative 24x. And then negative 6 times 3 is negative 18. No like terms to combine. So, and of course, this is what we would have to do to evaluate this using FTC1, which is, of course, to find the antiderivative of the integrand here, the function we're integrating. And so I have to expand it out first because there's no like product rule. I can't find the antiderivative of this and the antiderivative of this binomial and just multiply those, right? Think about going the other way with our product rule for derivatives. So what is the antiderivative? Well, term by term, we just use the constant multiple rule, pull the 32 out, and then power rule, right? Add 1 to 3 gives me x to the fourth divided by 4. So that's the power rule for finding antiderivatives. Antiderivative of x squared is x cubed over 3. And then the antiderivative of x squared over 2. And the antiderivative 18x, negative 18x is, or negative 18 rather, is negative 18x. And so here's my antiderivative. And now I'm going to evaluate this at 2 and 0. I'm going to simplify it a little bit. Of course, 4 goes into 32 8 times. 24 divided by 3 is 8. 24 divided by 2 is 12. And so now we're just plugging in x equal 2, plugging in x equals 0. I hope you can see when I plug in x equals 0, all of these are 0, so they combine to 0. And this is just evaluating a polynomial, which is what we did in problem number 1. And so when I evaluate this, I get 108. They want to know both the antiderivative, and if you look at read carefully the instructions, they say without an arbitrary constant. So they don't want the plus c in this case. So I'm just going to write out my antiderivative here that I'm using. Okay. And then, of course, the value of this definite integral comes out to be 108. Okay, so I hope this helps on questions 1 through 4.